Welcome, climate-curious listeners. Today we're diving into the crystal ball of our planet's future. Ikinai only, this crystal ball is powered by artificial intelligence and enough data to make even the most ardent spreadsheet enthusiasts swoon.
That's right, Mark. We're talking about simulating climate change scenarios, or, as I like to call it, the Weather Channel Extreme Edition.
Buckle up, folks, because we're about to take a wild ride through the world of AI-enhanced climate modeling. It's like The Matrix, but instead of dodging bullets, we're dodging rising sea levels and extreme weather events. So, Tom, imagine if we could combine the processing power of 1 million smartphones with the predictive abilities of Nostradamus. That's essentially what AI-driven climate change simulations are doing.
Absolutely, Mark. These simulations are like the ultimate game of climate sims, but instead of controlling virtual families, we're modeling entire ecosystems, weather patterns, and even human behavior.
You know, I once tried to predict the weather for my cousin's wedding. Let's just say my sunny with a chance of confetti forecast didn't quite pan out. These AI models, though, they're crunching data faster than a squirrel with a nut addiction.
And the practical implications are huge. We're talking about helping cities plan for sea level rise, farmers adapt to changing growing seasons, and policymakers make informed decisions about everything from energy policy to disaster preparedness.
But let's address the elephant in the room, or should I say, the polar bear on the melting iceberg. Some folks might be wondering, can we really trust a computer to predict something as complex as climate change? Now, Tom, let's talk about ensemble models. It's like the climate science version of The Voice, but instead of judges, we have multiple AI simulations all singing different versions of our planet's future.
Exactly, Mark. These ensemble models run thousands of simulations with slight variations. It's like playing What If on a planetary scale. What if we reduce emissions by 10%? What if we plant 1 billion trees? What if everyone switches to electric vehicles?
And the beauty of this approach is that it gives us a range of possible outcomes. It's not just saying the future will be X. It's saying, here are the most likely scenarios, and here's how probable each one is.
I've seen these models in action, advising government bodies on climate preparedness. For instance, a coastal city used AI-driven sea level rise simulations to identify vulnerable areas and plan long-term infrastructure. It's like SimCity, but with real stakes.
The key takeaway here is that these AI models aren't just giving us a single, deterministic view of the future. They're providing a nuanced probabilistic forecast that accounts for the inherent uncertainty in complex systems like our climate. Now let's dive into something that keeps climate scientists up at night: tipping points and feedback loops. Tom, care to explain what these are for our listeners?
Gladly, Mark. Imagine you're pushing a boulder up a hill. At first, it's a steady effort, but suddenly, you reach the top and the boulder starts rolling down the other side, picking up speed. That's a tipping point in climate terms.
And feedback loops are like the boulder creating an avalanche as it rolls down, making the situation even more extreme. These nonlinear phenomena are notoriously tricky to predict, but AI is changing the game.
Absolutely. AI algorithms can be trained to recognize patterns that might indicate an approaching tipping point, like changes in Arctic Sea ice coverage or Amazon rainforest dieback. It's like having an early warning system for climate catastrophes.
So we're not just predicting the weather anymore. We're predicting the behavior of entire Earth systems, including how they might suddenly shift or amplify each other. It's mind-boggling stuff, but crucial for understanding our planet's future. You know, Tom, if we were to map this out on a Wardley map, we'd see AI algorithms for climate modeling moving rapidly from the custom-built to the product stage. It's becoming a key tool in the climate scientists' arsenal.
That's a great observation, Mark. It really highlights how AI is transforming from a novel approach to an essential component of climate research and policy planning. Let's take a moment to map this out using Wardley Mapping. Mark, Can you walk us through how AI-enhanced climate modeling fits into the bigger picture?
Certainly, Tom. If we start by identifying the key components, we have climate data at the bottom as our foundational element. Moving up, we have AI algorithms, then ensemble models, and at the top, we have climate policy decisions.
I see. And how does this affect the overall strategy for addressing climate change?
Well, given the positioning of these elements, we can see that there's a strong push to move AI algorithms and ensemble models further to the right, making them more standardized and accessible. This could democratize climate modeling and lead to more informed decision-making at all levels.
Fascinating. So the key takeaway from this map is that investing in AI-enhanced climate modeling could have a ripple effect, improving our ability to make data-driven climate policies across the board.
Now let's look at the draft Wardley map provided in the book. It shows a climate modeling ecosystem in transition, moving from traditional methods to AI-enhanced approaches. The map suggests that the strategic focus should be on accelerating AI algorithm development and improving ensemble models.
Interesting. It's like watching the evolution of transportation from horse-drawn carriages to electric cars. But for climate science, the map also highlights the potential disruptive impact of quantum computing. That's like adding a rocket booster to our climate models.
Exactly, Tom. And just like how we needed to build roads for cars, the map shows we need to focus on data infrastructure and standardization to really leverage these AI capabilities.
The map also emphasizes the importance of integrating socioeconomic factors and tipping point identification. It's not just about predicting temperature changes, it's about understanding how these changes will affect societies and ecosystems.
Absolutely. This Wardley map really drives home the point that AI-enhanced climate modeling isn't just a scientific tool, it's a strategic asset in our response to climate change. It's giving us a roadmap to a more sustainable future, quite literally. Well, folks, we've journeyed through the fascinating world of AI-powered climate simulations. From ensemble models to tipping points, we've seen how artificial intelligence is giving us an unprecedented look at our planet's possible futures.
Indeed, Mark. It's clear that AI is not just a tool for predicting the weather. It's become an essential ally in our fight against climate change. Who knew that robots could be so green?
So, dear listeners, next time someone asks you about the weather, you can wow them with your knowledge of AI-enhanced climate modeling. And remember, in the Climate Change Challenge, knowledge isn't just power I, it's our lifeline to a sustainable future. Until next time, keep it cool, but not too cool. Climate-wise.